Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth, but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MNRAS on the 24th of June, 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun, but since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows, maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us. This is known as blue shift, or away from us. That's what we call red shift. And still, to make sure that their findings were correct, the team used lots of different methods and comparative analyses. Everything confirmed their conclusions. There indeed are 3 planetary candidates, with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open new doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers use different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now, let's look at the most exciting and promising of these worlds. Gliese 667cc is a mere 22 light-years from Earth, but even though it seems close, it's still around 206 trillion kilometers away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way farther away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth. It's about 2.4 times our planet's size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet. This time, it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they've found out that the planet needs 242 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, This world might be more hospitable than Venus since its host star is a bit less luminous, 80% of our Sun. Towai 733b is a recently discovered world. It was found in 2023. It's out there 245 light-years away from Earth and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does it mean there could be life on this super Earth? Time will show. GJ 1214b is located 40 light-years away from Earth. This planet is a super Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that's practically drowning in water. The sizzling temperatures and crazy high pressures on GJ 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo on being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working in exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there is still a mystery to us, even though we're talking about a planet that's close. Super-Earth TOW 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within the star's habitable zone. Experts say that Towai 715b might have once had an atmosphere thicker than that of Neptune, and now, the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet.
In April 2023, astronomers found something exciting: a runaway black hole. This thing is moving through the universe at an incredible speed, about 3.5 million miles per hour. It's 4.5 thousand times faster than the speed of sound. They found it accidentally. Researchers noticed that there was some weird straight line in Hubble images. After some digging, they realized there was a moving black hole. As it moves, it compresses the gas on its path, literally creating new stars along its journey. So it's leaving a beautiful, long trail of stars behind it. And when I say long, I mean it. Its tail is 200,000 light-years long, which is like the length of 2 Milky Ways. Turns out one end of this star trail connects to a distant small galaxy. This is probably where the black hole came from. Most likely there were 2 supermassive black holes whirling around each other. And then another galaxy came along with its own supermassive black hole and ejected one of the original ones like a mean kid, which is why it's called Runaway. There might be a 9th planet with the very original name, Planet 9, in our solar system. if it exists, it's probably somewhere far beyond Pluto. Astronomers think so because some rocky objects near Neptune move in a weird way, as if they were influenced by the gravity of a large, unseen planet. Planet 9 might be a gas or ice giant, 7 times the mass of Earth. One of the ideas is that it could have existed in our solar system, but then bumped into something huge and ended up with a crazy long orbit around our sun. If we actually discover it, it could change our understanding of the solar system. A new telescope is coming soon, equipped with the largest digital camera ever built, and it will start scanning the sky in 2025. Maybe it will finally spot this mysterious planet. Another awesome discovery was made in 2023. The James Webb Space Telescope found over 500 planet-like objects in the Orion Nebula. Some of them are roughly the mass of Jupiter, so they're literally called Jupiter mass binary objects, or jumbos. They just float out there with no stars, and they're not really stars or planets themselves. What's even crazier is that in about 42 pairs of them, the objects are orbiting each other, even though planets aren't supposed to do that. On top of that, such large objects shouldn't form and exist without a star at all. So now, astronomers are trying to explain this. Perhaps jumbos have formed in places where there was enough stuff for big planet-like objects, but not enough for stars? Or maybe all of them were ejected from their star systems for some reason. Who knows? But now we definitely need to study them. The black hole in the center of our galaxy, Sagittarius A star, used to be super weird. Luckily, it didn't run away like that other one, but it was completely crazy in the past. Astronomers found 2 supermassive structures called the Fermi bubbles and Rosetta bubbles. They spanned about half the width of our entire galaxy, and they've been towering over the Milky Way for over 2 million years now. And scientists think that it's our black hole that created them. It seems like when it was at its peak activity, it had a wild, energetic eruption that lasted about 100,000 years. This event probably left these bubbles. In 2023, the James Webb Space Telescope took a striking, super detailed image of the so-called Herbig-Haro objects. These objects are called Herbig-Haro 46/47. They're basically young stars surrounded by beautiful patches of nebulosity. You can see the stars being surrounded by a disk of material that feeds them as they grow for millions of years. They're located at about 1,470 light-years away, but they're actually not our main topic of discussion. What's much more interesting is this weird thing right below them, a space structure that looks like a question mark. What is this thing? No one knows for sure. It has an orange-red color, which hints that it might be super distant, far from our galaxy, maybe even billions of light-years away. Some think that this strange question mark is probably the result of 2 or more galaxies merging together. One of them was a bit curved, so it's probably a distorted spiral galaxy. The curve might be the tails being stripped off as they spiral towards each other. The other one was rounder and smaller, like a regular spherical one. The gravity games never fail to amaze us. Astronomers started searching for extraterrestrial megastructures. They think that if there's another intelligent civilization out there, they could have built something incredibly huge to power their technology. For example, like Dyson spheres. Hypothetical structures around stars that use the star's energy as fuel. Astronomers analyzed some historical telescope data that detects infrared signals. They spotted some weird signals that could hint at the presence of these structures. In total, there are 7 such candidates right now. All of them are coming from red dwarf stars, which are redder, smaller, and less massive than the Sun. Another research institute found 53 potential candidates. They're still not sure what exactly causes these signals, but it could be not Dyson spheres, but some huge debris. It looks like there are some mysterious structures in the center of our galaxy. In 2023, the James Webb Space Telescope has taken a detailed picture of the Sagittarius C region. It's right near the center of the Milky Way. This image showed a dense area where stars are forming. There were many young stars and dark clouds that blocked the light from the stars behind them. That's a very packed place, with about 500,000 stars of different ages, sizes, and colors. This place is very chaotic and extreme. Now, scientists are using it to study star formation. But the weird part is that they noticed something else: the large region of ionized hydrogen. It looks like cyan in the image. This area is about 25 light-years long, surrounding the lower side of dense cloud. And it looks like there are some needle-like structures. They seem to be located randomly, and astronomers have no idea what they are. So now they have to study this in more detail. Astronomers have found a super rare massive galaxy. It's called JWST 7329, and it's absolutely ancient. Our entire universe is about 13.8 billion years old, but the stars in this galaxy seem to have formed around 13 billion years ago, so just around 800 million years after the Big Bang. Also, this venerable elder has 4 times more mass in stars than our Milky Way does today. This strange discovery challenges what we know about galaxy formation and the nature of dark matter. Everything we know tells us that galaxies shouldn't have formed so early. There shouldn't have been enough dark matter for that, but here we are. So, perhaps our models need some revision. There was an incredible astronomical event called AT 2021 LWX, which is also called Scary Barbie. It was an unbelievably bright burst of energy that happened on April 13, 2021. It's one of the most energetic space events ever observed. No galaxies or quasars were nearby. So what in the world happened? At first, astronomers thought that it was caused by a supermassive black hole pulling in a massive star. But after some studying, they think it's probably because a giant black hole had some crazy dinner. It probably ate a large amount of gas, possibly a giant molecular cloud. The titanic black hole in question is between 100 million and a billion times the mass of the Sun. This is one of the most massive known and active black holes. Astronomers found the oldest strand of the cosmic web ever seen. The cosmic web is what we call a huge structure of the universe that's made of interconnected filaments of galaxies and dark matter. They're like a framework for galaxies and other structures, playing a crucial role in their formation. The filament we're talking about is made up of 10 closely packed galaxies. It's unimaginably huge, stretching over 3 million light-years. And it looks like the newly discovered strand is very ancient. It occurred only 830 million years after the Big Bang. It's probably anchored by a luminous quasar. This discovery makes us question how exactly galaxies are formed and what exactly happened to our universe after the Big Bang.
When you explode planets, things get red hot. Atmospheres are stripped away, stuff is flying apart, everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Sometime before the explosion, you're hovering in almost complete darkness. Below, you see the moon, or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury, and right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart, and then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. The appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume, 85% of Mercury, and finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, it knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1/600 of them. Unfortunately, you won't be able to do that because you pressed the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust, but 12-18 kilo. Then you spot bright, burning meteors flying toward you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 200 miles thick. But that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach a blue marble of your home planet. What will its insides look like scattered in space? From above, Earth looks pretty. 71% of its surface is blue because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume. 84% of Earth. You see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area, but in most places, it's 7 ft thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then the flying pieces get solid again. Ah, it's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 IF. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core, 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong it evaporates smaller planets like Mars and Earth. The Sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful. Gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way. Neptune looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and other metals. Scientists have a wild theory. What if our entire universe is actually inside a black hole? This is called the black hole cosmology. Some scientists have the idea is that our observable universe and everything we see around us might be tucked inside a black hole, which exists inside another parent universe, or even multiverse. And then this multiverse could also be a part of the bigger one, and so on. Like a stacking doll. Sounds like pure science fiction. But this is based on some curious facts. When scientists create the timeline of our world, they say that everything started from a singularity. If you kept squeezing a giant ball smaller and smaller, at some point, it would get super dense before it crushed. Well, it's hard to imagine, but in space, it's possible to squeeze a crazy amount of mass into a teeny tiny point. This point is called a singularity. The matter gets crushed into an infinitely small space, less than an atom, and it holds all the same mass. of everything, while taking basically no volume. Inside this singularity point, things get so intense that the normal rules of physics just stop working. Everything we know, time, space, matter, breaks down and can't be applied anymore. Basically, what happens from now on is beyond our understanding. So scientists say that this was the starting point of our world. When the Big Bang happened, it's like this tiny dot with everything inside it expanded to everywhere. This started forming the universe as we know it. And here's the thing. Scientists assume that singularity also exists deep within the black holes. General relativity says that a black hole is born when something really big, like a huge star, collapses under its own weight. Gravity gets stronger the bigger the mass is. With a mass of a huge star tens of times bigger than our sun, this little point would have an unbelievable gravity. That's why it starts sucking in all the stuff around it and curves the fabric of space-time so much it looks like a hole in space. And this would be the center of a black hole. It's a dot where all these things fall into and get crushed into an infinitely dense point. So, could our universe itself be just a little singularity dot inside of a huge black hole inside of another universe? That would be wild. Now, it's not that easy to compress something so much that it literally warps space-time. You'd need to squeeze it like crazy. If you wanted to make a small black hole, like a human size, you'd need to shrink them down to the size of an atomic nucleus. If you want a black hole the size of a chickpea, you'd have to compress our entire planet to that. But our universe is 99% empty space. There are trillions of miles of just nothingness between the stars. If you were to pack all the matter in the universe together, the result would be surprisingly small. Everything around us, including galaxies, stars, planets, and dust, would only fill about 1 billion cubic light years. It would be a cube about 1,000 light years on each side. For comparison, our Milky Way alone is 100,000 light years in size. That's how sparse the universe is. But at this density, it would also be very, very massive. The resulting mass would likely collapse into a black hole. And here's the wild part. This resulting black hole would be roughly the same size as the universe itself. It would also have the same mass and energy, as well as the same average density. The size or radius of the black hole grows together with its mass. The more stuff it eats, the bigger it is. But its density works the other way around. The black hole gets less dense as it grows. For a size that big, of our entire world, it would be pretty sparse as well. And it's not the only coincidence. We have this thing called the Hubble radius, also known as the cosmological event horizon. If we imagine our observable universe as a giant bubble, then think of its edge like the farthest part of the universe we can see. When you stand in a field and look around trying to see as far as you can, your eyes will draw a circle. This is like that. There might be more beyond that point, but we'll never know. Beyond this horizon, the light from distant parts of the universe will never reach us. That's because light travels at a certain speed, and the space between us and those regions is expanding too quickly. It's like running towards something while the super strong wind tries to blow you away. Until we stay on Earth, we're cut off from those far-off corners forever. The black holes have something eerily similar called an event horizon, or the Schwarzschild radius. This is the point of no return. It's this imaginary line that's often depicted as a light contour around the black holes. Anything crossing an event horizon falling inside is lost forever. No light, no matter, no information can escape from there. Black holes' gravity is way too strong, so they're perfect space vacuum cleaners. And as we mentioned before, if we create a black hole the size of the universe, they would have the same mass and the same event horizon radius. While some scientists think these could just be random coincidences, others believe it's a clue that our universe might actually be inside a black hole. The theory also suggests that our universe might not be the only one. It could exist in one of many black holes scattered throughout a larger multiverse. In this crazy model, each one of them, both in our world and our parent world, could lead to its own universe, with its own set of physical laws and structures. That would be some weird chain. There's this theory that says that universes could be born inside of black holes. Sort of. It's called the Einstein-Cartan theory. This idea talks about singularity as well, but in a different way. It says that instead of collapsing into an infinitely dense dot, the matter might create a wormhole. This is like a tunnel through space and time. This wormhole, also known as an Einstein-Rosen bridge, could connect two different places of our universe. In that case, one side of the tunnel is the black hole, and on the other side, there could be a whole new universe forming. So, it could work like a teleport. As soon as you pass the event horizon, you travel to the new world. But in that case, there should be an exit. Some scientists made it up and called it a white hole. It doesn't literally exist, not as far as we know, but it could be possible, somewhere on the other side. It would serve as an exit of a wormhole, an area where matter is always ejected instead of pulled in. So it's like, you can't throw anything in there, it would get expelled immediately. That's all purely hypothetical, of course. All this stuff fits well into the concept of the Big Bounce. This idea says that instead of our universe beginning with a singular Big Bang, it bounced from a previous state of collapse. Remember the squeezed ball analogy? Well, maybe there used to be another universe ball that got super compressed to a minimum size before rebounding and expanding again. So, instead of a universe born from nothing, we might live in one that's a cosmic recycling of another. There's also another version of this theory, sometimes called shockwave cosmology. This idea says that the Big Bang could have been caused by a boom inside a black hole, and this could create the expanding universe we see today. As the universe expands and the matter density decreases, the black hole would eventually transform into a white hole, the reverse of a black hole, where matter is expelled instead of pulled in. But even though we have all these interesting connections, they're not evidence. There are no experiments or observations that could prove or disprove these wild theories, so they all remain speculation for now, but at least it's fun to speculate. There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like Earth, the moon is made of layers: a crust, mantle, and core. However, the moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the moon itself. It's surrounded by a hard, rocky mantle, but it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the moon influences our seas and oceans, causing tides with its gravity, but it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing mineral. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything, from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So if the moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the moon is not just a cold, boring rock. Instead, it's dynamic, living and breathing, with moving forces beneath the surface. NASA used new special tools to discover this. The Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the moon's gravity as they go. It's like they were feeling the moon's invisible pull in different places. If the moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the moon, even if they can't actually go there. And the spacecraft intentionally crashed into the moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years. That's some million-dollar questions. The moon's core generates heat, just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. First, the moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the moon is much cooler than Earth in general, speaking temperatures of course. With temperatures dropping to 128.9 degrees Celsius on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Beyond the moon itself, it also tells us more about other celestial bodies. If the moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh. Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. That's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty, hollow tunnel, hence a lava tube. On Earth, we see lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, a place where Apollo 11 first landed, and it's at least 103.6 meters deep, and all these cave systems have remained hidden just beneath the surface, untouched for millions of years. Only now they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden beneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. The best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 17.22 degrees Celsius. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So, Humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure, there's a huge potential for exploring these caves and finding some awesome stuff, but even if we manage to find a miracle like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves for a future base, showing that the race to explore and settle the moon is heating up. Asteroids are a serious, very real danger. Some of them are big enough to cause a lot of trouble if they collide with Earth. One asteroid in particular, 99942 Apophis, is making headlines these days. A new study has revealed there's a small chance it could hit our planet during its close flyby in 2029. But the question is unusual. Will the asteroid survive this encounter? Apophis, which got its name from Apep, the Egyptian deity of chaos and disorder, has become one of the most infamous asteroids. Discovered in 2004, this space rock is about 335 meters wide. It's about the height of the Eiffel Tower in Paris. Because of its size and the close flyby predicted for 2029, astronomers classify Apophis as a potentially hazardous object. Those are asteroids and other space objects that pass close to Earth and are big enough that we really need to pay attention to them. Right now, scientists say the chances of a collision are slim, less than 1 in a billion. So at the moment, we can probably claim that Earth is out of danger. But the same can't be said about the asteroid itself. When Apophis passes close to Earth in 2029, the planet's gravity is likely to shake it so violently that it may experience something like an earthquake, a cosmic asteroid quake, if you will. The stress from this gravitational force will probably cause parts of the asteroid's surface to crack off and fly into space. And even though this might not be a full-blown disaster, and the asteroid won't fall apart completely, it's very likely to lose some material during the flyby. Some of this debris might just stick around in orbit, while other bits could fly off into deep space. Over time, this catastrophe could affect Apophis's rotation, causing it to spin differently or tilt in a way it hasn't before. And this is a phenomenon scientists are really interested in, because it could teach us a lot about how asteroids react when powerful gravity is pulling on them. Now, let's get back to Earth. Well, we haven't left. Anyway, even though the asteroid isn't big enough to wipe out the planet like the asteroid that destroyed dinosaurs, it's large enough to cause serious damage to a large city if it ever collided with Earth. It could mess with the climate all over the planet too. At the moment, it looks like the space rock will sail past Earth at a distance of around 32,200 kilometers. It's still worryingly close, but far enough to avoid a collision. To put it in perspective, that's less than 1/10 of the distance between Earth and the Moon. So, while Apophis likely won't hit us, this flyby could still cause problems for some of the satellites orbiting Earth. They will be much closer to Apophis than we are. The key point is that we can't rule out the risk of collision for a few more years. As Apophis gets closer, astronomers will keep a very close eye on its trajectory to make sure it doesn't veer off course due to the influence of Earth's gravity. In fact, this gravitational pull could actually cause some serious changes to the asteroid itself. Now, even though Apophis is not likely to cause a global disaster, if it were to hit Earth, the consequences would still be pretty severe. The impact could destroy an entire city, and the resulting climate changes could mess with food production for years. It wouldn't be an extinction-level event, but it would still be a huge deal. Apophis is not the only asteroid we need to worry about. Scientists are constantly on the lookout for other asteroids that could potentially cause harm to our planet. Thanks to new technology, astronomers can now track dangerous space rocks from way farther out in space. One cool new method they're using involves studying meteor showers. These showers are actually caused by long-period comets that have been orbiting the sun for hundreds or even thousands of years. As these comets pass by, They leave behind a trail of dust and debris, which can end up creating meteor showers when Earth passes through them. Scientists analyze the properties of meteor showers, like their speed, direction, and where they come from. This can help them trace the particles back to their parent comet or asteroid. It's actually a big deal because it means we might be able to spot potentially hazardous asteroids long before they get close to Earth. The upcoming Legacy Survey of Space and Time project, which is being run out of the Vera Rubin Observatory in Chile, is going to help astronomers track these space rocks from even farther away. Astronomers are going to create a detailed map of the sky and the regions where meteor showers are most likely to occur. It'll help them predict which asteroids might become a problem for Earth in the future, giving us plenty of time to prepare or come up with a plan. But even now, there are many space rocks that can potentially cause a lot of trouble to our planet. Let's look at some of them. Here's the asteroid Bennu. Astronomers discovered it in 1999. This carbon-rich rock is about 487 meters across. It's the height of the Shanghai World Financial Center. Didn't you know that? At the moment, this asteroid is the greatest threat to Earth that we are aware of. But don't panic yet. The collision won't happen for a long time. In fact, scientists calculate a 0.037% chance, which is about 1 in 2,700, of Bennu striking Earth on September 24, 2182. I won't be around then. If Bennu does hit our planet, the impact would release so much energy it would be enough to cause massive destruction in a large region. But luckily, it wouldn't wipe out the entire planet. Still, if Bennu hit a city, the consequences could be catastrophic. NASA's OSIRIS-REx spacecraft has recently visited Bennu and returned with samples, so scientists are learning more about this asteroid all the time. The next asteroid, 29075 1950 DA, is another one to keep an eye on. It was first discovered in 1950 but wasn't seen again until 2000. Right now, scientists say there's a very slim chance, 1 in 34,500, that it could hit Earth on March 16, 2880. 800 years into the future, so am I worried? Nah. If it did strike, it would release so much energy it could lead to a global catastrophe, potentially wiping out humanity. Or not. Our next asteroid has been discovered only recently, 2023 TL4. It was spotted in October 2023. It has a very low chance, 1 in 181,000, of striking Earth on October 10th, 2119. Man, they got it down to the day. If it were to collide with our planet, the impact would release a lot of energy, which would have a devastating effect for large areas. So, while the arrival of this asteroid is a long shot, this asteroid is still worth keeping an eye on. This asteroid is known as a lost asteroid because it hasn't been seen since 2007. No wonder, it has a very uncertain orbit, and we can't predict its movements. NASA says there's a tiny chance, about 1 in 10 million, that it could strike Earth on March 3rd, 2030. If it did, the energy released would be able to cause huge regional damage. Finally, we've got this Space Wanderer, 1979 XB. On the one hand, it hasn't been seen since 1979. On the other, scientists believe there's a very low chance, 1 in 1.8 million, that it could hit Earth on December 14th, 2113. Mark your calendars. If it did, the impact would cause a lot of damage and devastation, but it would not lead to the end of humanity. In any case, even though the chances of an asteroid hitting Earth are low, the consequences of such an event could be huge. That's why scientists are so focused on studying these space rocks and tracking their movements. Thanks to new technologies, we can track dangerous objects from farther away and catch them earlier. It can give us more time to react and come up with some effective solutions.
Okay, here's the deal. Something is bound to happen that can affect everything we've ever known about space and time. You've heard about black holes, right? That denser-than-life type of phenomenon that usually exists in the center of galaxies? 2 of them, located 9 billion light-years away from Earth, are expected to collapse into each other. And my oh my, I do not want to be around to see that. Let's get one thing straight. Black holes are the most powerful things in the entire universe that we know of. If they decided to go all Revenge of the Sith on us, we'd be doomed. A black hole was once a massive star that went supernova, meaning that the star collapsed onto itself, and the sheer magnitude of the explosion created a black hole in its place. Oh, by the way, black holes do not pull things inside like a vacuum cleaner. That's just a popular myth. Say we were to replace our sun with a black hole at the center of the solar system. Not much would change, except that maybe we'd all freeze. Yep. But black holes can do something much worse than vacuum stuff. They can delete the universe itself. If a black hole was to follow a normal timeline, it would go from its creation to total disappearance. But this process is very, very slow. I'm talking about billions and billions of years before a black hole loses its mass entirely. That happens because they're constantly losing their mass every single second. Black holes radiate their mass away, like a boiling teapot loses its water as steam. Yet, things rarely go as planned, both in our lives and apparently in the universe itself. So it wouldn't be that much of a surprise to find out that two black holes are en route to collapse. That's what scientists have found out recently. And let's just say that this is one of the reasons why the scientific community is freaking out just a little bit. The first question that comes to mind is, what does that mean for us humans? Total annihilation? No need to be this dramatic. The best case scenario, we'd be in for an interstellar type of experience. Roll me in, please. Let's rewind a little bit to understand how this would happen. 45 years ago, a group of scientists began noticing a weird behavior coming from a galaxy far, far away. The galaxy is found 9 billion light-years away, and its scientific name is a mouthful, but let's just call it Super Far Away Galaxy. You might be asking yourself, well, how did scientists observe this black hole so far away if it doesn't emit any light? Good question. That's because black holes gather disks of gas around them, and they emit some of this material into space. These jets can be detected from a distance of millions of light-years. Now, if these hot gas jets are directed towards space, then scientists give these black holes a special name, blazars. A particular blazar has been gaining worldwide attention recently. Long name, but let's just call it Andy. Imagine you're a scientist at Caltech and you're looking at a blazar in your radio telescope and you notice its strange behavior. Its brightness goes on and off, like the ticking of a clock. At first, you don't understand what's happening over there in a distant corner of the galaxy. But then, you realize there must be another black hole circling the first one. In other words, scientists discovered that Andy was being orbited by another blazar, Gomer. And the regularity of their twinkling can only mean they are close to a total collapse. It gets worse. Each of the two blazars is estimated to be a few 100 million times the mass of our Sun. Have you seen our Sun? It's huge. It's already 333,000 times the mass of our Earth. This means we're destined to face something out of our league. Now, this is not the first time scientists have detected something like this. In September 2015, the LIGO Observatory detected a collision of two black holes. Each of them was as heavy as 30 suns, and an equivalent of 3 solar masses was released once they crashed into each other. And guess what? This gravitational wave passed through Earth at the speed of light. But we really weren't affected by it. Maybe you were sleeping and felt something weird in the air, but nothing significant happened to us as a species or to our planet. But that's because the blast was weak. The thing is, the expected collision between Andy and Gomer will send unprecedented gravitational waves throughout galaxies, and they will reach the solar system. But what is this shock wave actually capable of doing? Well, it could stop our Sun from releasing gas for a few minutes, which means it would stop heating the solar system. So, let's say you were going about your summer day, and out of the blue, the atmosphere froze for a few seconds. Doesn't sound too nice, huh? But that's actually a better possibility than the next one. In one of the worst-case scenarios, a blast from the collision between Andy and Gomer could break bonds between atoms and make everything disintegrate. You, me, your cat, we'd all turn into flying particles floating in the vacuum of space. This may sound scary, but scientists say that an atom is made out of 99% empty space. This means that everyone on this Earth, all 8 billion of us, and everything that exists, planets, objects, animals, are all made up of 99% empty space. So perhaps all that Andy and Gomer would do is separate all of our atoms and desolidify us. Then again, the blast could mess with the fabric of space and time as we know it. You remember Albert Einstein, right? Crazy hair? He's the name behind the theory of relativity. Einstein discovered that time is relative. It's always dependent on the observer. This would mean that time is not the same throughout the cosmos. Why though? Well, because Einstein's theory of relativity is also a theory of gravity. Einstein discovered that gravity is the effect that objects have on the fabric of space-time. Every object that has a mass, including you, me, your cat, and our planet, creates a warp or a distortion in the fabric of space-time that causes it to bend. The bigger the mass, the bigger the gravitational force, and the bigger the distortion on the fabric. It may sound complicated, but hey, this is what creates different perceptions of space and time throughout the cosmos. This is why you'll age differently on Earth and on Jupiter. This is why time passes completely different for astronauts on long missions and for people that remain on Earth. And this is why a collision of two mega blazars could mess with our perceptions of space and time due to the sheer force of its gravitational shockwaves. Got it? Not to mention that black holes are already a huge warp in the fabric of space-time. You remember that Interstellar scene, right? Where the lead character bends the space-time continuum through a black hole? Now, don't try this at home though. As far as we know, anyone who chooses to go inside a black hole has no guarantee of making it home again. Scientists say that this blazar explosion will happen in approximately 10,000 years. But wait a minute. If this blazar lies 9 billion light-years away from Earth, it means that these two black holes should have already collided long before our solar system and home planet were born. You see, the solar system was born around just 4 billion years ago. And since it takes us 9 billion light-years to receive the light emitted from the blazars in the first place, this means that the collapse of the two blazars already took place, and it'll reach Earth 10,000 years from now. This means the shockwaves are already making their way through the galaxies at this very moment. But still, it's not something even your great-great-great-great-great-great-great-grandchildren will be around to see.
The universe is a big, mysterious, and ever-changing place. But just like we have baby photos that show how we looked when we were little, scientists also have a baby picture of the universe. Only they were able to look 14 billion years into the past. How is it possible? Well, let's figure it out. Imagine winning the Oscars of Science for a picture that shows the entire universe when it was just a baby. Scientists achieved this fantastic feat using NASA's Wilkinson Microwave Anisotropy probe. To take this picture, they built a super cool satellite, launched it into space, and collected massive amounts of data about the universe. This image turned out to be a cosmic treasure trove. It helped answer some of the universe's biggest questions, but also revealed a few new mysteries. This groundbreaking data confirmed the standard model of cosmology and told us that our universe is around 13.7 billion years old. Plus, it showed us that the elements in our regular periodic table make up only a tiny fraction of the universe's recipe. To be honest, this is not quite a photo in the usual sense. Of course, we cannot actually photograph what happened so long ago. The picture we're talking about is called the Cosmic Microwave Background, or CMB for short. Now, the CMB is like a faint glowing light that fills up the entire universe in every direction. These clues that can help us understand how the universe evolved into what it is today. CMB is a super cool glow that fills up the entire universe. You see, when you look through a regular telescope, the space between stars and galaxies seems pretty dark. But with an amazing radio telescope, we can actually detect that this empty dark space is filled with a super faint and even glow. This glow is all around us, and it's not coming from any star or galaxy. This is the cosmic microwave background, and it's strongest in the microwave part of the radio spectrum. The CMB is a frozen treasure, super chilly at around 270.6 degrees Celsius. Brrr, that's colder than any winter you've experienced. This ancient light formed about 380,000 years after the Big Bang, which happened around 14 billion years ago. So, we're looking way back in time. In the beginning, the universe was like a thick fog of incredibly hot plasma. It was almost 277,760 degrees Celsius. It was so hot that atoms couldn't even exist yet, only wild electrons and protons bouncing around like crazy. Because of this super hot fog, any light that tried to travel got scattered by those mischievous electrons. It was basically like trying to see through a foggy car windshield. But then, the universe started expanding in all directions, just like a cosmic balloon getting bigger and bigger. And it's still expanding today. As the universe did that, it began to cool down. When it turned 380,000 years old, it finally cooled enough for electrons and protons to come together. These tiny particles started to combine, forming mostly hydrogen atoms. When that happened, the universe finally became transparent, like a clear window. The moment of this magical transition is called the recombination epoch. Once the foggy era ended, the light could travel freely. The universe became like a vast playground for light to bounce around and explore. And as you know, light has a certain speed, 300,000 kilometers per second, to be specific, and it takes some time for light from distant places to reach us. So in other words, the CMB is the oldest light in the universe. It's like a capture from a moment when the universe just started to become clear and transparent. As this light traveled through space, it went through all sorts of adventures, like the formation of stars and galaxies. Along the way, it lost some energy and transformed into microwaves, which our eyes can't see, and that can be detected only with special tools. Also, there are some tricky things that can mess with the data. For example, galaxy clusters. These are big groups of galaxies hanging out together in space. When the ancient light from the CMB travels across the universe, it encounters these groups. And these sneaky clusters try to leave their marks on the CMB. They distort the patterns in the ancient glow, like smudging the ink in the important ancient book. That's why scientists have to invent techniques and supercomputers to help clean up this mess and decode everything properly. Due to all this, the CMB isn't perfectly smooth. It has a few little bumps and patterns. These weird patterns make it unique, kind of like the universe's fingerprint. Scientists have been using amazing tools like the Cosmic Background Explorer and Wilkinson Microwave Anisotropy Probe to study these patterns. The COBE, our cosmic camera, took the first ever map of the sky in microwaves from 1989 to 1993. Why do we study it? Well, because the CMB can help us learn so much about the early universe, stuff like how it expanded, how much normal matter and mysterious dark matter it had, and even the overall shape of the universe, and much more. We're basically playing detective with the cosmos, trying to decode the mysteries of our world by little clues and prints. What are the results? Well, awesome tools like the Wilkinson Microwave Anisotropy Probe helped us to learn more incredible facts. For example, we found out that we can actually only see 5% of the universe. Imagine the universe as a cosmic pie. Scientists learned that 68% of it is made up of something called dark energy, and 27% is dark matter. Only a tiny 5% is made of normal matter, the one that we, humans, can see. So most of the universe is like this hidden realm we can't even imagine. We also found out what happened in the beginning of times. Picture the universe right after the Big Bang. It was so tiny, way smaller than a proton. Everything we see today was crammed into this itsy-bitsy space. The rules of quantum mechanics, which let weird and wild things happen, were in full swing back then. Matter and energy were like playful adventurers, borrowing from the future and disappearing into nothingness. Then seismic inflation happened, and the universe suddenly expanded like popcorn on a cosmic scale. It became a trillion times bigger than it was, creating waves of gravitational chaos everywhere. Some gravitational waves filled the baby universe like a sea, and their patterns left unique fingerprints on the CMB light. And all that learned thanks to the pictures of the CMB. Anyway, NASA has this awesome plan to study the universe's baby picture. They're going to use a really cool observatory called PIPER, which stands for Primordial Inflation Polarization Explorer. Imagine PIPER as a special space balloon that's going to fly up high in the sky from a place called Fort Sumner in New Mexico. It has two powerful telescopes that sit in a hot tub-sized container filled with liquid helium. This liquid helium is super cold at around 269 degrees Celsius. But PIPER loves the chill because it's extremely sensitive. What is its mission? To learn all about the early days of the universe, right from its first baby picture. When PIPER is up there, it's going to look very carefully at the CMB, trying to find some hidden patterns that hold the secrets of how the universe grew and changed over time. This spy with a magnifying glass will be examining 85% of the sky. PIPER's launch is scheduled for late September. You can even watch the exciting balloon filling action live on the Columbia Scientific Balloon Facility website. It's going to be out of this world fun. So, the cosmic microwave background is like a time-traveling storyteller, giving us valuable clues about the universe's incredible past. Isn't that awesome? Space is full of surprises, and there's so much more to discover. Keep your eyes on the stars, and who knows what else we'll find out there. Usually, when we look at the photos of astronauts in space, we can see that they're sorta attached to the spacecraft. But there was one brave astronaut who took a wild step into the great unknown without any safety line connecting him to the shuttle. This brave man was Bruce McCandless, and he did that stunt back in 1984. How did he come back, you may ask? He did this cool trick using a nitrogen jetpack, which NASA called the Manned Maneuvering Unit. At first, he tried out some test maneuvers in the Challenger's payload bay. And only after he made sure it was all right did McCandless decide to go for it and glide a staggering 100 meters away from the shuttle. A bit of sad stats here. Out of the 430 people who have made the leap into space, 18 have sadly lost their lives, which gives us a fatality rate of just over 4%. With these numbers, it's safe to say that space shuttles are the least safe means of transport out there. Duh! Alright, let's make it a tad brighter. If we crunch the numbers a bit better, we can get a smaller percentage. But how? Well, 4% is a bit misleading because when we count, we take all the space flights. However, some people flew several times, which reduce the probability. With over 600 seats filled across 113 shuttle flights, the true fatality rate for shuttle missions is actually closer to 2%. Let's test your general knowledge now, shall we? So, what was the first living thing ever sent to space? If your answer is a monkey, you aren't right. Those who said dogs. Sorry you guys, but it's not correct either. On the 9th of July, 1946, fruit flies became the first living creatures to make it to space during a suborbital V-2 rocket flight. Then, on the 20th of February, 1947, these little guys safely returned from their journey, opening the door for future human space exploration. Before we sent to space mammals, like the rhesus monkey Albert Secco in 1949 or the famous space dogs, scientists spent a lot of time studying fruit flies to see how they reacted to radiation and the conditions of space travel. Researchers started using fruit flies for experiments back in the 1910s. Guess why? Because we humans share a lot of genes with these yucky pests. Imagine hearing some creepy music all of a sudden when there's nothing but darkness around you and nobody is there to help you. Right now, imagine how elevated this experience was for astronauts who heard some creepy music in their space shuttle. Months before the moon landing, Apollo 10 astronauts were orbiting the moon testing equipment when they heard strange audio noises. Astronaut Eugene Cernan noted the eerie sounds, joking they were like weird music. At that moment, the astronauts didn't have contact with mission control. They were over the moon's dark side. Although the noises resembled something from a sci-fi film, NASA downplayed them as they were focused on the astronauts' mental health. Despite years of speculation, the source of the sounds remains unknown, with theories ranging from radio interference to charged particle activity. Cernan later remarked that they didn't take it seriously and didn't report it after the mission. Chances are, we've already received messages from new friends from other galaxies, but we just failed to understand them. In August 1977, some astronomers using the Big Ear radio telescope at Ohio University picked up a strange narrowband radio signal from the constellation Sagittarius that lasted for 72 seconds. The signal buzzed at a frequency of 1,420 MHz, which is significant because it matches the natural emissions from hydrogen. This frequency had been flagged by scientists almost 2 decades earlier as a likely choice for extraterrestrial civilizations trying to reach out to us. They dubbed it the WOW signal after one of the astronomers wrote "wow" on their printout. We've never heard that signal again, and no one has been able to explain its origin satisfactorily. After spending about a month in space, astronauts start losing quite a lot of skin from the bottoms of their feet, especially those tough calluses they've built up over time. One astronaut even called mission control in a bit of a panic when he noticed a chunk of his heel drifting off in zero gravity. But no worries. As the old calluses peel away, new ones spring up on the tops of their feet. They need that grip to hold on to all the restraints, kind of like airborne trapeze artists. Going number 1 and seeing blood is as scary as it sounds, and yes, in the weightlessness of space, blood doesn't settle in the lower body in the same way it does on Earth. This can lead to some alarming situations on board. Natural urges are universal, regardless of location. There are 2 main reasons why astronauts are unable to use traditional toilets in space. First, water is an extremely valuable resource aboard a spacecraft. Second, there's no gravitational flow of water in space. The drinkable water on a space station is contained in pouches and is used accordingly. In a weightless environment, a specialized device with suction and disposable bags is used for waste collection, with the storage being replaced every 10 days. Additionally, spacecraft are equipped with complex systems designed to recycle and filter liquid waste, converting it back into usable water for the astronauts' daily needs. As if that wasn't enough, spending an extended period floating around in space brings another challenge. The body may lose its bursa sacs, those handy little cushions that sit between our hip joints. While this may not pose an immediate issue in the zero-gravity environment, returning to solid ground can turn the simple act of sitting down, whether in a chair or on a toilet, into a real struggle. The fluid shifts that contribute to blood-related issues don't stop there. They can also wreak havoc on astronauts' sinuses, creating a constant feeling of congestion. It feels like living in a stuffy room all the time, where relief seems just out of reach. Thus, the challenges of long-term space travel add up, making the experience as daunting as it is thrilling. Another challenge astronauts run into is vision loss, also known as ocular syndrome, which sounds all science-y. While the exact cause is still a bit of a mystery, it's thought that extra pressure on the brain can mess with both the retinas and optic nerves, And here's a fun fact, it mostly affects guys. By the way, you might assume that shutting your eyes in space means it's pitch black, but that's not the case. Because of high levels of radiation, astronauts can still see bright lights when they zip through certain parts of their orbit. It's a pretty strange phenomenon that keeps them on their toes, even with their eyes closed. 12. Switching gears, let's talk about bone health in space. It turns out that being weightless can really take a toll on astronauts' bones. Like, they can lose up to 2% of their bone mass every month, which is pretty wild. But the good news? They've come up with new exercise routines that help fight off that bone loss. So, while space travel definitely has its challenges, researchers are working hard to keep astronauts in tip-top shape as they explore the universe. The Big Crunch is a cool theory about how the universe might end, and it's basically the opposite of the Big Bang. So imagine the universe expanding for ages, but then it hits the brakes and starts collapsing in on itself, maybe even forming a huge black hole. Scientists are looking into this by checking out the universe's density. If it's too dense, such a collapse might really happen. At first, people thought that gravity would eventually take over and stop the expansion from the Big Bang. But then we found this mysterious thing called dark energy, which is actually speeding up the universe's expansion. Because of that, it seems like the Big Crunch is pretty unlikely. Right now, the evidence shows that dark energy is here to stay, so the universe will just keep on expanding forever.
You know what? 8 out of 10 people worldwide can't see the Milky Way anymore. And in just 100 years, it might turn into a forgotten tale from the past. It's not that the galaxy is disappearing, but that the cosmos is fading from view. Back in our grandparents' day, they could look up and see this vibrant tapestry of stars. But nowadays, we're lucky if we can even count them on one hand. This has nothing to do with nature. It's all because of the creeping threat of something called light pollution. Next time you walk around a big city after dark, take a moment to notice the large number of street lights, neon billboards, and office buildings shining all night long. Those endless city lights create an artificial brightness that competes with the natural glow of the stars. This is light pollution, and it's getting worse. Every year, Earth gets 10% brighter. That means if someone is born today in an area where you can typically see around 250 stars, when they reach 18, they'll only be able to see about 100 of them. Unfortunately, that's already a problem in big cities, where looking up at the stars is becoming something that you can only do in planetariums. It's gotten to a point where, during an earthquake that knocked out the power in Los Angeles in the 90s, many residents called emergency centers to report a massive silvery cloud in the night sky. But what they were actually seeing, perhaps for the first time, was the Milky Way. When you look at Earth from space, you can see vast areas of North America, Europe, the Middle East, and Asia all lit up. Singapore, Qatar, and Kuwait are some of the most light-polluted countries. On the flip side, remote places like Siberia, the Sahara, and the Amazon rainforest are in total darkness. Light pollution shows up in many forms. First, there is glare, like when you're driving and those bright lights literally make your eyes hurt, leaving you very uncomfortable. Then there is clutter, like Times Square with its crazy mishmash of different bright lights all over the place. Light trespass is when light sneaks into places it shouldn't, like a streetlight shining right into your bedroom. And finally, there is over-illumination, which is just using way too much artificial light for no good reason, like keeping all the office lights on throughout the night when no one is even there. All these forms of light pollution aren't just stealing the beauty of the night sky, they're also interfering with astronomical studies. When we rely too heavily on artificial lights, it messes up the work of Earth-based telescopes. And when that equipment can't do their job properly, we end up needing even more expensive space telescopes like Hubble and James Webb. And let's face it, that costs us billions. Turning night into day actually affects all of us, not just astronomers. Nighttime light messes with our sleep schedule and our body's internal clock. This clock keeps things like brain activity, hormone levels, and cell functions on track. So when it's disrupted, it can lead to serious issues like depression, insomnia, heart problems, or worse. One key process that gets messed up is the production of melatonin, a hormone that kicks in when it's dark. Too much light at night lowers melatonin levels, leading to stress, anxiety, headaches, and sleep deprivation. Blue light is the main villain here. You might think that turning on night mode and getting that orange glow in your phone screen is enough, but it's not. Blue light is also present in LED bulbs, the kind we use at home and in city lighting, because they're cheap and energy efficient. My point is that blue light is basically everywhere, and it's a real challenge to avoid it completely. This is also a big part of why we're not entirely sure how bad light pollution is nowadays. I mean, some statistics suggest that this issue increased by 49% over 25 years, up to 2017. But the real figure may be even higher. The thing is, blue light has shorter wavelengths, and the satellites we depend on today struggle to detect it accurately, meaning they don't quite capture the full extent of the light pollution caused by LED lights. Animals are lost and confused too. Their sleep patterns are also affected. A study from Germany revealed that blackbirds in urban areas are getting active much earlier than those in natural habitats. They wake up and start singing up to 5 hours sooner than their country cousins. Migration behaviors are messed up, especially for birds like sparrows and thrushes who travel at night. You see, they rely on the moon and stars as their internal GPS. So you can imagine how disoriented they get when they spot something like Las Vegas's massive sphere, lit up by 1.2 million LED bulbs. The intense brightness hides stars and disrupts their navigation across thousands of miles and continents. And it's not just that. Artificial lighting is unfortunately causing more birds to crash into skyscrapers and high-rise buildings. Insects, like mosquitoes, are also affected by light pollution. Yep, they're kind of gross, so it might not bug you if they're attracted to artificial lights and meet their fate. But remember, they're a crucial food source for many animals, like bats or frogs, so disrupting their populations could throw off entire food chains. Nighttime lights are causing problems underwater as well. Marine creatures near brightly lit panels off the Welsh coast are changing their behaviors, and fewer sea squirts and sea bristles are hanging out near those lights. Another example involves sea turtles. They typically lay their eggs on beaches and often return to the same spots for years. But when those beaches are too bright at night, female turtles might become confused and decide not to lay their eggs there. Now, do we really need all this light? It's hard to say. Some people might feel safer at night, while others think the opposite. You see, it's usually the glare that messes up our sight. Here's an example. If there's a super bright lamp blocking our view, say at a gate, we can't see anything but the light. But check this out. If we partially cover the light with our hands, suddenly we can spot an intruder. Wow. What I mean is that more lamps don't always mean more safety. It's all about using them the right way, and doing things like dimming lights can actually enhance security. Plus, it could save you some cash. Speaking of which, light waste has a pretty big impact on the economy. Take a Cobra Head streetlight, for instance. The light projected directly by it is only 30% of the total light it emits. In the US alone, roughly 1/3 of the light at night goes to waste, and that adds up to a staggering annual cost of $2.2 billion. Electric lights aren't all bad, of course. They have done some good stuff for us, like making our days longer so we can get more done and have some fun after work. But we can totally minimize this issue. Turning off all the lights would be awesome, but let's be real, that is very difficult, if not impossible these days. So, what can we do? Get those fancy controls like dimmers, timers, and motion sensors to make sure our lights are super efficient. Go for warmer colored lamps instead of those harsh blue ones. Oh, and consider using fully shielded light fixtures, like those cool vintage table lamps. They direct the light down where you need it, so you don't get that annoying glare or light scattering everywhere. Plus, when you cut down on wasted light, you're not just helping out the planet, you're also saving some cash on your electric bill. Talk about a win-win!
Now see here, Astronomers have recently discovered a neutron star, aka a dead star, spinning at an extraordinary speed of 716 times per second. It makes it one of the fastest spinning stars we've ever found in the universe, and it's not just about its speed. The surface of this neutron star is erupting with super powerful explosions almost non-stop. But before we dig deeper into the mystery of this neutron star, let's figure out what these stars really are. They form from the remnants of massive stars that are at least 8 times the mass of the Sun. When such stars exhaust their nuclear fuel, they can no longer counteract the force of gravity pulling their matter inward. This leads to the collapse of their cores, triggering a massive supernova explosion that blows away the outer layers of the star. What's left behind is an ultra-dense core. That's a neutron star. These stellar remnants are incredibly small, typically just 19 kilometers wide. At the same time, they pack in more mass than the Sun. The density of neutron stars is also overwhelming. Imagine taking the mass of 2 suns and squeezing it into a sphere about the size of a city. A single teaspoon of neutron star material would weigh around 10 million tons. That's the same as the combined weight of 85,000 blue whales. Such an extraordinary density is what gives neutron stars their immensely powerful gravitational fields. When matter falls onto a neutron star, it accelerates to speeds of millions of miles per hour before slamming into the surface. The energy released from such impacts is truly astonishing. Despite its name, inside a neutron star, there are not only neutrons. A few protons survive down there too. Normally, protons repel each other since they have the same positive charge. But in a neutron star, that crushing gravity forces them so close together that the strong nuclear force takes over. It pulls them toward the neutrons like they're all part of the same team. Inside the star, things get stranger the deeper you go. Near the surface, neutrons clump into blobs, kind of like neutron gnocchi. A bit further down, these blobs link together into long chains, forming what scientists call the spaghetti layer. I'm getting hungry. At even greater pressures, the spaghetti chains fuse side by side, creating flat sheets. Think neutron lasagna. Keep going even deeper, and the lasagna eventually breaks down into a uniform mass. But even then, the structure isn't smooth. There are gaps, long tube-shaped voids that look a lot like penne pasta. So, inside a neutron star, you've got layers of gnocchi, spaghetti, lasagna, and penne. And each of them represents the mind-bending results of physics under insane pressure. Okay, I'm definitely having Italian for lunch today. Now, the recently discovered neutron star is part of a binary system, 4U 1820-30, located in a dense star cluster, NGC 6624. This cluster is situated near the center of the Milky Way galaxy, approximately 26,000 light-years from Earth, in the direction of the Sagittarius constellation. The record-breaking spin of the star is extraordinary. If we take a period of not a second but a minute, it'll be over 42,000 rotations per minute. At the same time, the newbie ties with another neutron star, PSR J482446, which spins at the exact same speed. Such extreme rotation rates are rare and make these stars cosmic outliers in terms of behavior and properties. Oh wait! We can't but mention our neutron star's binary partner. It's a white dwarf, a dense remnant of a star similar in size to our Sun. This white dwarf is pretty fast, too. It orbits the neutron star once every 11 minutes. This makes the couple a binary system with the shortest orbital period ever observed. Imagine a stellar object zipping around its partner faster than the time it takes to prepare a cup of coffee. Yep, that's the kind of speed we're talking about here. This tight, rapid orbit shows how powerful gravitational forces are inside the system. You might be wondering what makes neutron stars spin so rapidly. It's something called the conservation of angular momentum. Let me explain. When a massive star collapses into a neutron star, it shrinks dramatically. Such a rapid compression gives an instant boost to its spin. It's like an ice skater spinning faster when they pull their arms inward. And the smaller the star gets, the faster it spins, which results in extreme rotation rates. In binary systems like this one, 4U 182030, neutron stars can achieve even faster spin rates. Their trick is to steal matter from their companion stars. This process is called theft. Haha, no, accretion. The stolen matter carries that very angular momentum, which adds to the neutron star's rotation speed. The accreted material can also build up on the neutron star's surface. Eventually, it triggers powerful thermonuclear explosions. They release immense amounts of energy, temporarily making the neutron star shine up to 100,000 times brighter than the sun. It allows astronomers to study the intricate details of these extreme environments. NASA's X-ray instrument on board the International Space Station, officially called the Neutron Star Interior Composition Explorer, and thankfully nicknamed NICER, observed 15 thermonuclear explosions on the surface of our neutron star between 2017 and 2021. One of those bursts displayed a unique pattern called thermonuclear burst oscillations. Those are highly asymmetric patches of brightness on the burning surface layers of accreting neutron stars. This pattern matched the spin rate of the neutron star and, thus, confirmed its extreme rotational speed. But wait, the best part is coming! While neutron stars are already extreme, there's another class of them that takes things to a whole new level. Magnetars. Magnetars are neutron stars with unimaginably strong magnetic fields, up to 1,000 trillion times stronger than Earth's magnetic field. These fields set them apart from other neutron stars. They can distort atoms in nearby objects, making life impossible anywhere near them. As for the energy density of a magnetar's magnetic field, it is so high that it's 10,000 times greater than the mass density of lead. Magnetars also produce bursts of X-rays and gamma rays that are so powerful they can temporarily outshine entire galaxies. These bursts are often triggered by starquakes, violent shifts in the magnetar's crust caused by their own magnetic fields. For example, a gamma ray burst from a magnetar in 2004 was so strong that it disrupted Earth's ionosphere. It hit Earth, and it was so intense that several satellites picked it up. The SWIFT satellite, built specifically to detect gamma ray bursts from across the universe, didn't just detect the blast. It got hit with so much energy that its sensors got completely overloaded, and SWIFT wasn't even facing the burst. The energy was so strong it passed through the spacecraft and still overwhelmed its cameras. If a magnetar were located as close to Earth as the Moon, its magnetic field would erase all credit card data on the planet by wiping the magnetic stripes clean. That's the level of power we're dealing with here. Magnetars are extremely active, but for a relatively short time. Their intense magnetic fields decay after about 10,000 years. After that, they stop emitting strong X-rays and gamma rays. Astronomers think that there are at least 30 million inactive magnetars in the Milky Way galaxy alone. These silent cosmic relics are scattered all over the galaxy.